Mm. Okay, any questions? If there's no questions, I'm going to begin. Let me, am I sharing my screen?
No.
Thank you. Let me state that I did a bunch of grading this weekend. So take a look at the grades. Let me see if I can show that. I think I've got Lab 00 and Lab 01 graded the second time. And I've got most of the labs graded one time. I have not graded last week's lab yet. And I did grade last week's lecture handout. Oh, and I graded quiz 1A. So the first quiz has been graded. Any question about any of that? All right. Don't forget to take a look at the resources of the week. We're now on week 5. We need to talk about that. So click on the resources of the week. Then there should be 5 links. Resources of the week. Well, let's see if that's going to go. Yeah, week 5. Tutoring services, disability support services for week 4, counseling and health services for week 3, the Penguin Pantry for week 2.
Yeah, I have a question about the quiz time change. So like some of us, like myself, I know, work a 9-to-5 job. And then we're here in lecture until like after 8 o'clock. So it's kind of hard to do it from 8 to 8. Because like I get home from work and then it's like I gotta feed my son and things like that. And then to spend time to do the quiz.
If you didn't make an announcement or a statement when I asked people to make a statement, I'm sorry I can't help you now. But it is from 8 p.m. on, let me see what I've got that. 8 p.m. on Tuesday to 8 p.m. on Wednesday. So you have 24 hours to take the quiz. Why is that not going to the weekly announcements? It's not going. All right. Let's just go back. Anyways, I make the announcement that you have to take the quiz from 8 p.m. to 8 p.m. It's no longer 11:59 p.m. to 11:59 p.m. And that was requested by almost all of the students who left a remark. So for all of the quizzes, they're now going to be held 8 p.m. Tuesday to 8 p.m. on Wednesday, with the exception of the final. I think it's from 8 p.m. Wednesday to 8 p.m. Thursday. Any questions about that? And I asked for people to make comments. Where was that?
You just passed it. It's on week 3.
Thank you. Right there. And nobody had trouble that when they stated but they could do it from 8 p.m. Tuesday night to 8 p.m. Wednesday night. That was one of the options. And that one, for the people who commented, that one seemed to work for everyone. If it doesn't work for you, fix your schedule so it will work, because all the quizzes are now changed to that time, with the exception of the final. And it's similar, but I think it's going to be on Wednesday at 8 p.m. till Thursday at 8 p.m. That has to be changed. March 9th till March 10th, and I don't know what day that is. So hopefully look it up. All right. I'll leave that and adjust that. We got a lot to talk about today, so let me get started. Am I recording? Stop the share, make sure I'm recording. Yes, I am. Come on. Must have too many things open. It's not switching. So today I need to talk about Lab 6. I also have to discuss and start the Unknown project. On the Unknown project, here it is here. We're going to be doing this Unknown project online, but you are going to be identifying an unknown bacteria. What I'm going to send you is a number, which is going to be your unknown number. You're then going to run some tests, and throughout the rest of the term, you'll be running tests and deciding which test to run and all that. And this project is worth 75 points. So read the rationale, project format. You're going to be given an unknown number, and then you're virtually going to be running tests, meaning over the online, to identify this bacteria. You can use what you want, like the lab textbook, lab manual, Berge's manual to help you do things. You must use dichotomous logic. Essentially, dichotomous logic means you're going to be picking a test that has two possibilities, positive or negative. For example, on the Gram stain, you can choose the Gram stain and you will get Gram positive or Gram negative. So on the Gram stain, you can have a positive result and a negative result. And let's say you have the positive result. So we cross this one out. I don't see an easy way to cross that out. Oh, there we go. Of course, that doesn't help much. And you have the positive, so we'll highlight it. And then you pick another test. And let's say you pick BR glucose. And that can have a little bit more than a positive result. You can have an A, you can have a AG, and you can have a negative result. Let's say you get a negative result. You then pick another test. And we'll go with, what's a good test? Catalase test. And it can be catalase positive or catalase negative. The point is, I can't really draw this together. We did the gram stain. Well, maybe I can do it in a table. So we have the gram stain. And the result was positive. Oops. Then we did PR glucose. The result was negative. And then we did the catalase test. The result we're going to say is positive. And the idea is you're starting to identify your unknown. Any question about any of that? Which test you do will depend on what your results are and what the possibilities are. And where do I have that? I think it's here. I have 5. These are all the tests you can possibly run. And you'll only be running the ones that you want to run. What you'll want to do is, once you get your unknown number, take a look at the unknown list. And what I should do is download this so it's a little bigger.
When will you be sending out these numbers?
Hopefully tonight. If not tonight, tomorrow. So this is the table of the unknown bacteria. To here are the gram negatives. After this line, it's the gram positives. So you will have one of these species, and then these are the different tests that you can run to help identify the species. It goes further. Oh, just one more. Now, if you were to request each test, I would have to have about 6 requests to answer, and multiply times 20 people times 6, whatever that number is. It's an ungodly number. And I decided that's too much response for me to give on one project. So I am going to give you the first 3 tests. Then you're going to be following dichotomous logic, because the first test you're going to run is the gelatin test. And a good reason for doing that test is it splits the species down about 50-50, regardless of where the results are. And another reason for doing this one first is this test takes the longest. You don't get results for 1 week. Any questions about that? So I'll give you this test, and I'm going to give you the grams test and the PR sucrose test. However, you're going to be doing the gelatin test. If I send out the unknown number tonight, you'll start this test tonight. And then you're going to set up the gram stain on, let's see, today's Tuesday. And you're not going to get the results until Tuesday. So you'll set up the gram stain on Sunday. And you won't finish it, gram stain, until Tuesday. But on Monday, you'll then set up the PR lactose test. And then on one email, I'm going to send you the results to gelatin, the PR lactose test, and the gram stain. Any questions
if-
about any of that?
If the tests are digital, why aren't the results instant?
Because it's going to be following like you're actually doing the test. So when you do a test, you have to spend the amount of time that the test takes before you're going to get results.
We set up like multiple tests at once.
No, because that wouldn't be following dichotomous logic. If you do not follow dichotomous logic, your project will be graded down. And we'll talk about the grading in a little bit. Anyways, the first 3 tests are given to you, and you're following dichotomous logic because you're going to set up the gelatin test first. And set up the the gram stain, and then you're starting the PR lactose. The PR lactose test takes only a day to run. So you set that up Monday, and then I'll get you the results to all 3 of the tests on Tuesday. The reason for this is I can send out one email to everybody giving you the results to 3 tests. And that's going to reduce my number of emails or contacts down by 60. That will make the future contacts between you and me doable for this project. And that is, you will be having, on average, 3 or 4 more tests that you're going to ask. And that'll make 3 or 4 contacts between me and you. Okay? Which to you guys, that's no big deal, but to me, that's going to be 4 times 20, that's going to be 80 different contacts, which is doable for one project. All right, so you look at this table for determining what test to run, and where the heck did I do it there? I don't know. Looks like I shut it down. Let's shut down. Any questions about the different species, the unknown species list? And the different tests you can run?
I have a clarifying question. So I'm just to make sure I'm understanding this. So we're waiting until you send us all of those to proceed further, right?
Well, hopefully tonight I'll send you your unknown number. Okay?
Well, right, but you said that you're gonna do the first 3 tests for us already across the board. So are we just gonna wait for those before we start going further?
No, you need to put your unknown number in your unknown notes. So once I get that to you, you should put your unknown number in your unknown notes page. The unknown notes page will be where all future contact will be between you and I. So after the first 1 or 2 emails from me, you need to record all of your daily activities and obviously your unknown notes, your unknown number in your unknown notes page. You should put in your test results here for your unknown project. You should also put up your test results and then what the conclusion is. Let me explain what the difference between the result and a conclusion is. I'm going to send you a picture of the test. Let me go ahead and go to the earlier student. Oh, look at this, because I'm not supposed to show this. I'll try and do an old one. So here is a capsule test. And this student looked at this picture and saw that there were a purple background and purple cells, and then a white halo around the cells. That is your observation. Okay, that is the result. The conclusion is whether this had capsules or not. And then they wrote their conclusion for whether they had a capsule or a not. No capsules. That is your interpretation, which is the conclusion. You understand the difference between a result and a conclusion. Let me look at it right here. Here is the VP result, the number 46, and that's the, it's not stated, but that's the negative control. And so they would say that the color is, I don't know, brownish. That's your observation of the result. And then you have to look up on the VP test, is this positive or negative for the VP test? And that's your conclusion. Any question on that? So in your unknown notes page, give your results, what your observation is, and then give your conclusions, what the interpretation of the picture is. You should put all your other notes concerning the unknown project here in your unknown notes page. The system will date it, so whenever you download the page, it will put the date and the time. I don't have a download button because I'm a teacher. I have a grader button. But you can put in an infinite number of pages here. Each time you update it, just download the page. Do not put things in the comment. I will use the comments. I don't even have that shown here, but I've got a button for putting in comments. Do not put things in as a comment. If you put it in as a comment, I'll just delete it because the comment is for me to give you information. And when you ask a test, what you should do is put at the end of that document you downloaded the test request. And then I will look at that and I will look at the unknown notes pages at least every other day. And then I will get you your results after the test has incubated. So each test has an appropriate incubation period, and you have to look up what that incubation period is. You can find that by just looking at the different tests. Most of them have an incubation period of about 2 days. There's only a few tests, like the Catalase test, which has an incubation period of you can get the results immediately. So there's the same day you ask for the Catalase test, you might get the results for the Catalase test on the same day you ask. But most of them have an incubation period, at least of 1 day. Most of them are 2 days. And then a few of them are longer, like the MR test takes 5 days. Where did that go? Methyl there it is. This one is the gelatin, takes 7 days. So put everything down here with the test request that you want to run at the bottom of the page. I'll get it, and then I'll send you the results. And it will be done in your unknown notes page. So except for the first 1 or 2 emails from me, everything will be in your unknown notes page. And you should put your first 3 results and interpretations in your unknown notes page. And that way everything will be together. If you want to look it up, you can find it in your unknown notes page. If I want to look it up, I can find it in your unknown notes page. Your unknown notes page will be graded, but it's only worth 5 points. Okay?
Should we all start with like the catalase test since it's the fastest, or do we start like by trying to figure out how much of the different species we can cut out with one test?
I want to look at the gram stain, the gelatin hydrolysis, and the PR sucrose to see what species are still possible and what you can cut out. Once you have that, you then ask for a test. And you could ask for the catalase test first, but it may not be the best test to ask for. And that will be up to you.
Okay, and I heard you mention earlier, like you want us all to finish this by at least 4 tests, right?
Sorry?
I heard earlier you wanted us to like finish the project by at least 4 tests.
No, some students will take longer than 4 tests. The lucky students will have less than 4 tests. I said about an average, students will be requesting 4 additional tests. Okay? And you have all term from whenever I get you the unknown number and your first results to do this project. The project is due March 5th about. The unknown notes page, it has to be done by March 5th. Okay, any questions about the unknown notes page? What it's for?
No, but I think something's wrong with your microphone.
Why?
Because it sounds really weird for everyone.
Yeah, you kind of sound like Darth Vader.
Okay. Well, my voice is hoarse.
It doesn't have anything to do with your actual voice, it's the mic.
All right, let me finish up with this project and then I'll switch to the microphone. It has a speaker on it. I'm not using it because, well, it hurts my ears and I've got a hoarse voice. But let me finish talking about this project. Let's close this page. I don't want to close it there. Well, I'm not going to close it. Oh, there it is. Let's close that. Sorry, that's in my way. That page. I think I've got the directions here. So the unknown report were 75 points. It should be typed and written using bullet points. It should be using 12-point font. If it's smaller than 12-point font, I'll have a hard time reading it. You should have your daily descriptions. And where you're going to get all this information for writing up your lab report is you come to your unknown notes page. Now, if you do the unknown notes very formal, the unknown notes page will be no different from your lab report. However, the unknown notes page does not have to be formal. You can, I don't know, write in shorthand, you can abbreviate, you can do what you want in your unknown notes page, as long as it has the requirements I stated earlier. But if you do your requirements very formally, the unknown notes page will look very similar to your lab report. And we have a sample lab report right here. It's called the sample journal. When you write up your unknown lab report, you should have a cover information, which should be part of the first page. And then everything should be dated. Let's move it in a little ways. You should have on each day your observations, which are the test results. You should have the activities that you're doing. That'll be the new test you're going to run. And then you should have your conclusions. Where is it? There it is there. And that would be the interpretations for your observations. You can set it up this way. This author did it: observations, activities, conclusions, but you might want observations, conclusions, and activities. The reason why the professor wrote it this way is that he set up the test on one day, and then 2 days later or a few days later, he got the observations for that test, and then he wrote the conclusions. Okay? So most of the time, you'll be setting up the test first, and then you'll get your observations and make your conclusions. Any question about that? You do have to have a table stating what tests were helpful in identifying your unknown, and then identifying your unknown either in this table or you can do it in a flow chart where you give the tests that identify your unknown, or do it in a table, flow chart or not a table. And this one looks like it was identified as Staphylococcus aureus, and he reduced it to 3 possibilities simply by the pigment test and the gram stain. The next test didn't help him, the Catalase test. And then he did beta hemolysis, which actually narrowed it down to Staphylococcus aureus. But he wanted to be more thorough, and he did additional tests. You can do one additional test, meaning this person's already identified it as Staphylococcus aureus by the hemolysis test. You can do one more test to confirm your identification. However, do not do, let's see, 1, 2, 3, don't do 3 additional tests, all to confirm that it's Staphylococcus aureus. I'd have to go look up why this person decided that maybe I should consider E. faecalis, for example, because that one was closed off after the pigment test. All right, let's go back to the grading. So don't omit data to make your project look better. Talk about everything. You may include photographs and pictures. It's not required. You may include tables. There's only one table or flow chart that is required, and that's to identify your unknown species at the end. Each day should have a date, beginning with the date. You don't have to discuss the step-by-step details of a test just state what test you run. Like if you're running the gram stain, state, I ran the gram stain today. My cells showed up to be purple circles. My conclusion was that they are gram-positive cocci. Okay? So you don't have to go in each of the steps for the gram stain. I know the gram stain. This state, you ran the gram stain. You should give your thoughts and words for the reports. So after you did the gram stain, I came to the conclusion that my unknown was gram-positive cocci. So I could throw out, I don't know, all of the gram-negative cells, and I decided to do the pigment test next. So you should give your logic in. All right, there's including the table outlining the process you used to identify your unknown. You should also have a paragraph at the end discussing the unknown species that you've identified. In this paragraph, you should have a literature cited for where you got the information for your unknown bacteria. And like I said, you should have a table or a flow chart giving the species that you identified. And you should have a formal citation page, which may only have one entry. Is the grading criteria, the logic of the test performed, the completeness of the report, what tests were run, why they were run, what are the conclusions of the test. Diagrams, photographs, and tables are helpful, but they're not required. You should be organized, clear, neat. And how it's going to be graded is not shown here, but it's shown here. Unknown grading rubric. Utilization of resources. You can get 10 points for that one. What dichotomous logic used? 10 points for that one. All the relative tests used. If you have all the tests you needed to identify your unknown species, when no tests were omitted, you'll get 10 points. Were the correct species included in each step? So at each step along the way, you should be identifying which species are possible. In the very beginning, all species are possible. You'll then have the gram stain, the gelatin test, and the PR lactose test. So you should state what species are now possible after that test. And you should state them, the species. Okay? And then you do, let's say you do the pigment test after that. You should then now state what species are possible. So are the correct species being included in each step? If you only get one species wrong, you're minus 2 points. The completeness of the report, all the information presented, you get 10 points. Effective and clear communication, you get 15 points. And then lastly, was the correct species identified? You'll get only 10 points. If the species was within the same group, like it's so Enterobacter aerogenes, and you said it was E. coli, it's within the same group, so you'll get 7 points. If it's outside the group, but the gram stain is correct, meaning the gram stain is still gram negative, but it's outside the group, you'll get 5 points. If your gram stain says it's a different species than what it is, you will get actually 0 points. Okay, total worth 75 points. Any questions about how this will be graded? All right. Let me remove this. And now let's talk about lab 6. And I'll switch to my headphone.
Are you able to try your headset so it doesn't sound like that, maybe?
I'm gonna do that now.
Okay.
I have to remove the thumb drive. Put in my headset. Which is why I wasn't using the headset. Because I was using the thumb drive to talk about the unknown project. Now, the trouble is if I cough into that, it'll be bad. All right, can you hear me now?
Yes, it's so much better.
Much better.
Much
Good.
better.
So the microphone on the laptop apparently is going out. All right, let's go to lab 6. Could be that one, but it could be this one. It's this one. All right, so today we're going to be looking at disk diffusion, the evaluation of disinfectants and antiseptics, and antibiotic effectiveness. Through the reading, I'm going to tell you to go over the learning objectives. Normally I'd read through that, but we're a little behind schedule here. We're largely going to be looking at the effectiveness of antibiotics on agar plates. We will discuss the effectiveness of antibiotics and disinfectants. So you should know the terms. Sterilization eliminates all viable organism, including endospores. Disinfection refers to the destruction of vegetative cells, not necessarily endospores. So when you disinfect a toilet, you are killing vegetative bacteria, but not necessarily the endospores. Disinfectants are chemical agents applied to inanimate objects. Antiseptics are chemical agents applied to living tissue. To evaluate the effectiveness of chemical agents to the surface of a nutrient agar plate, you inoculate the agar plate with a particular bacterium. Paper discs saturated with different chemical agents are then applied to the surface of the agar. The chemical agent then diffuses into the agar medium, establishing a concentration gradient around the disc. The discs are then, or the plates are then incubated overnight. The bacterial growth pattern around the disc is then observed. If there's a zone of inhibition, an area of no bacterial growth around the disc, the chemical is assumed to be effective for a particular bacterium. Conversely, if there's no zone of inhibition, the chemical is assumed to be ineffective. This is used with both antibiotics and disinfectants. It's very good when it's used against antibiotics. Why? Because when a patient takes antibiotics, the antibiotics have to diffuse through the blood, through the tissue, to get to the bacteria that's causing the site of infection. So that this diffusion from a disc through the agar is very similar to the diffusion of the antibiotic in a patient. However, this effectiveness is not very good when we're using it against a disinfectant. And the reason is when we apply a disinfectant, we're not using it so that the disinfectant diffuses through agar. Meaning normally when we use disinfectant, we apply it directly to the agent we're trying to clean. Any question about any of that? All right, take a look at this table. It tells you the different chemical agents and the general mode of action. The zone of inhibition size will depend only partially upon the sensitivity of the organism to the disinfectant or antiseptic. There are various other factors that affect the zone size, including the concentration of the chemical. The more concentrated chemical you have, the larger the zone of inhibition. The smaller the molecular weight of the agent, the further it'll diffuse. So the smaller the molecular weight of the agent, the larger the zone of inhibition. And then the density of the bacterial inoculum will also determine the size of the zone of inhibition. The more dense you have the bacteria, the smaller the size of the zone of inhibition. So there's many things that come into play determining the size of the zone of inhibition. The evaluation for antibiotic effectiveness. Antibiotics are categorized as bactericidal if they kill bacteria. So if you put an antibiotic on the disc, if it's bactericidal, it will kill the bacteria within the zone of inhibition. If the antibiotic is bacteriostatic, it will simply inhibit the growth of bacteria within the zone of inhibition. Any question about that? No questions, let's move on. With bacteriostatic antibiotics, whenever they are used, we are relying on the host immune system to eliminate the bacteria that's causing the infection, because a bacteriostatic antibiotic will not directly kill the bacteria. But you stop them from growing, and then the host immune system can remove the bacteria. The Kirby-Bauer disc diffusion test is the most common method used for testing antibiotics. The results of such testing help physicians in choosing which antibiotic to treat a sick patient. Bacteria are isolated from the patient and then grown on an agar plate. So you spread the bacteria on the plate, and before the bacteria grow, you let the bacteria be absorbed by the plate. So that's within 5 minutes. And then you put on the disc containing the different antibiotic resistance, meaning the different antibiotics. And then you incubate the plate, and then you look at the plate after incubation, a day of incubation. And you look for zone of inhibitions around the disc. For example, let me blow this up a little. this antibiotic either has no zone of inhibition around it or very little, and that one has very little zone of inhibition around it. This one has a small zone of inhibition, and that one a large zone of inhibition. Generally speaking, if everything were the same, we would say that this one would be the most effective antibiotic because it has the largest zone of inhibition. However, you can't do that because there are different factors that come into play for the size of the zone of inhibition. Maybe this antibiotic is much smaller in its molecular weight, so it's diffusing much better than these two. And these are larger antibiotics. So you have to go and look at a table to determine, is the antibiotic sensitive, or is the bacteria sensitive or resistant to the antibiotic? And I'll talk a little bit more about that. The filter disc has the antibiotic in it, and then the antibiotic diffuses out of the disc, creating the zone of inhibition. The antibiotic may simply keep the bacteria from growing, or it may kill the bacteria within the zone of inhibition. All right, so how do you determine whether a bacteria is sensitive or resistant to a antibiotic? Well, you have to measure the diameter of the zone of inhibition. So on this one, we take the diameter, measure it across from here to here, or here to here, or both, and take the average. On this one, you can't measure from here to here, but you could measure from the center of the disc to this edge and then double to get the diameter, or you can measure across this way. Sorry about that. Once you have the diameter of your zone of inhibition, you then look it up in a table. The National Committee for the Clinical Laboratory Studies, or NCCLS, sets, and then compare the measurement to the size of a sensitive one in the table. If the size is larger than the table size for being sensitive, then we can say that that antibiotic, that bacteria is sensitive to that antibiotic. If the size of the zone inhibition is smaller than the table says for resistance, then we say that the zone of inhibition of this bacteria is resistant to that antibiotic. And if it's in between, we then say it's intermediate. So we cannot simply look at the zone of inhibitions here and state that this one is resistant and that this one is sensitive. We have to measure the diameter and then look it up in the table. And if the diameter is larger than the table says it's sensitive, then it's sensitive. If it's smaller than the table says it's resistant, then we say it is resistant. Any question about any of that? How do we set up the Kirby-Bayer test? The procedure is given right here. you inoculate a nutrient broth from several bacterial colonies, and you make sure that the colonies are not more than 24 hours old. You then grow the broth so its turbidity is 0.04, 0.05 McFarland units, and that's approximately 1 times 10 to the 5th organisms per mil. This is grown to get to this density for less than 24 hours. You then take this density of fluid and inoculate a Mueller-Hinton agar plate. Excuse me here. We always use Mueller-Hinton agar when we're doing the Kirby-Bayer antibiotic testing. The pH is always between pH 7.2 and 7.4, and the depth is always 4 millimeters thick. The plate is also 150 millimeters. So we always use the same media and the same pH and the same agar depth. Why? Because when we use different media and certainly different agar depths, we will affect the size of the zone of inhibition, meaning the antibiotic will move at different rates through different media, and especially at different amounts of agar, the zone of inhibition size will be different because the antibiotic diffuses different on different depths of agar. So we all keep all of those variables the same so that they do not affect the zone of the inhibition. You then place the discs at least 24 millimeters apart, no more than 12 discs on a plate. And you apply the antibiotics 5 minutes after you apply the bacteria, but not longer than 15 minutes after you apply the bacteria to the agar surface. You then incubate the plates in a non-CO2 incubator for 16 to 18 hours at 35 degrees, and you incubate no more than 15 minutes after you add the antibiotic disc. After 16 to 18 hours, you then take a look at your plates and you measure the zones of inhibition. You use millimeters to measure the zone of inhibition and then look at the zone of inhibition in the NCCLS set of standards to determine whether the bacteria is sensitive, intermediate to, or resistant to that particular antibiotic. So there's the zone of inhibition being measured in millimeters, and that looks like it's about 20 millimeters. 20 millimeters for the diameter. This antibiotic is penicillin, the bacteria Staphylococcus aureus. Each antibiotic in each species will have a different zone of inhibition sizes in the NCCLS standard. For this bacteria with penicillin, I'm going to assume that's penicillin G. If the zone of inhibition is 20 millimeters or less, the bacteria is resistant to this antibiotic. It's not sensitive to this antibiotic unless the zone of inhibition is greater to 29 millimeters. And the measurement is 20 millimeters. So that means that this one is resistant to this antibiotic, penicillin G. Any question about any of that? If not, go over the terms of this lab and then do the laboratory exercise. You're not physically going to be performing any of these activities, but you are responsible for how to interpret the effectiveness of antibiotics using the Kirby-Bauer diffusion test. We have a little video for you for preparing a spread plate, and then review the steps using aseptic technique when preparing a spread plate. Inoculate as much of the agar surface as possible with the swab, and you inoculate the bacteria on the agar plate 3 times. So let me pretend. Getting a, can you guys see this? I'm
Yeah.
gonna assume you can see it. No, yes.
Yes.
Okay. So you have your cotton swab, you dip it in your bacteria that has 0.5 Macfarlane units. Squish the worst of it on the sides of the tube. And then you start inoculating the agar plate by spreading it everywhere. I really need a round one to be an agar plate, but you get the idea. Here we have a round one. I don't know if you can see this one, but maybe you can see that one better. So spread it around, going everywhere. And you're supposed to do it in what? You'll have to go at an angle, and then you rotate the swab a quarter of a turn. You rotate the plate a quarter of a turn, and then you repeat, spreading everywhere. The reason is you want the bacteria to go everywhere. Rotate a quarter of a turn, rotate a quarter of a turn. Hopefully you're seeing this. You do that 3 times, okay? And then when you're all done, you take the swab and you go around the edge of the plate, because when you're going like this, you might miss a little portion of the edge. And you need to get the bacteria to grow everywhere. I once had a student who she went da 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 da, and then she didn't have the agar growing everywhere. It was only growing on a few streaks, and she could not determine the diameter of the antibiotic zones of inhibition. So make sure you have the bacteria growing everywhere. Then view the following video clips to complete the virtual lab. Let me make sure that we have that.
So we don't have a number 1 on the worksheet. It starts at number 2.
Let me take a look at the worksheet.
This is the world's first reusable cotton swab. It removes up to 5 times more excess earwax. Recent studies show that standard cotton swabs are harmful to your ears. Instead,
Got a
doctors
commercial here. Yeah, it does have the Kirby-Bauer testing. This looks like a video. I thought that said it was a virtual lab. You'll need to watch the video from the lab manual. Well, there's the virtual lab there. Let me see if that works. It looks like the virtual lab is not going to work. So you can't do the virtual lab. Yeah, on the lat worksheet, it starts with number 2. Come back to here. On 1, all you're doing is watching the videos. And then on 2, you're using the Kirby bar susceptibility test prepared using a spread plate technique. Take the reading from the O on the right arm of the caliper. So when we come and look at the caliper here, there's the zone of inhibition. You don't read it from 10 here, because if you notice, this 0 isn't all the way over here. What to do is you read from this 0 here, so that this would be 15 millimeters. Everyone got that? Read the caliper from where this 0 is. Make your measurements. Yeah, let me see if I got the bacteria. So we're using E. coli, and you determine from the measurements which we're giving you, here, 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 and here, whether the bacteria is sensitive to the antibiotic, intermediate to, or resistant. And the first one we'll do as a group, ampicillin in the table here. The zone of inhibition is right here, and that's 15 millimeters. So write in 15 right there. And then the interpretation for E. coli at 15 millimeters for ampicillin, that is intermediate. The sensitivity of this zone of inhibition to that antibiotic is intermediate. Any question about any of that? So you put an I here. And then do that for cephalothin, gentamicin, and tetracycline. And here they are here. The measurements in the table, or the table here. Okay, any question about that? And then answer the question for question 3. Note that there's 1, 2, 3, 4, 5 requirements to question 3. And then answer the questions 1, 2, 3, 4, 5, 6, 7. And then submit your answers using the worksheet, not the lab module. Submit the worksheet for lab module 6. Any questions? If not, get started on lab 6. I will be here until 8:20 to help you if you have questions.